So in this particular case, we are now on lesson 7, which is sum and difference of identities. So we discussed these identities, okay? So I want to emphasize that we are not memorizing it. We are going to use it, but not memorize it. Okay. Now it says here, one of the applications for these new identities is to find exact values of angles that are not special angles. Okay, so when we look at this one here, okay, if we type this onto our calculator, it's not going to give us an exact number, right? So let's go type it in onto our calculator. Sine of 75 degrees. I gotta make sure that my calculator says degrees. Sine 75. Okay. So I can see already that it's non-terminating, non-repeating. That means it's not it's not exact. So what's exact? How can we figure out the exact value of that?
Like the root 6 plus root 2?
Yeah. We're gonna have that exact value for that. So, sine 75, well, what are the two special angles that you know that either you add or subtract that will give you 75? 45 and 30? 45 and 30. Those are special angles, yeah. 45 and 30. Okay, so let's break up the 75 into, we're gonna say 75 degrees. That's gonna be 45 degrees plus 35 degrees, right? So we can call alpha would be 45, beta is 35. Oh, 30, not 35. 30 only. So 45 and 30. So, okay. Can we figure out the sine of 75 now that we've broken them up into something that we are very, very familiar with? So what's sine of 75? We can say sine of 75. Okay. We know it's going to be sine of 45 plus 30. Okay, so this is your alpha, this is your beta. Now, let's go back to our sheet. Okay, what's our identity here? Sine of alpha plus beta. So that's going to be, this is our identity, right? Sine alpha cos beta plus cos alpha sine beta. Yeah? So let's put that in. So it's going to be sine alpha. This is my alpha. This is my beta. Sine alpha, which is 45, times cos beta. Cos beta is 30 plus cos alpha, which is 45, sine beta, which is 30. Okay. Can you pick it up from here?
Yeah.
The answer is yes. Yeah. So go ahead and pick it up from there and then see what number you're going to come up with. Okay, what did you get? Did you get root of 6 plus root of 2, all of that divided by 4? Yeah? Okay, good. Now let's go ahead, type this in onto your calculator and see if we're gonna come up with the same value. So if you do this, root of 6 plus root of 2, okay, I gotta put a brackets right there so I know that everything is being divided by 4. Okay, so this is the 0.96592526. This value is the approximate value. This is the exact value. And then when we actually type that in sine of 75, it's the exact same value, right? Okay, that's good. So this is exact. Okay, now this one is a little bit different because it's pi 12s. Now we have to think about, this is the challenging part, is think about what add or subtract that will give us pi over 12. Okay, I'll just give you the number here, the angles, unless you know it already. So tan of pi over 12, okay, is the same thing as tangent of pi over 4 minus pi over 6. Pi over 4, because if you multiply this by 3, that's going to be 3 pi 12, and then if you multiply this by 2, that's going to be 2 pi 12. Okay, so in this particular case, our alpha is pi by 4. Alpha is pi by 4. Beta is pi by 6. Okay, now let's locate what is the identity for that. So it's a difference of the angles. So that's going to be this one right there, right? So tan of alpha minus beta is equals to all of that. So tan of pi by 12 is equals to tan of pi by 4 minus pi by 6. And we know there's an identity for that. The identity is tan of pi by 4. Okay, tan of alpha minus tan of beta. Oh, beta is pi by 6. All of that is being divided by 1 plus tan pi by 4 times tan pi by 6. Where did I get all these? Oh, right here. Yeah, because we said that to be able to get the pi by 12, it's the same thing as pi by 4 minus pi by 6. Okay, I gave you that because that's a little challenging to think about at this time. Plus we want to speed up the video. So I split it up into alpha and beta. So this is a difference of the angle. So tan, the difference of the angle, and then I'm using this formula. Not formula, an identity. Okay, and then here I substituted the first angle, second angle, first angle, second angle. Okay, good. Now from here, what we can do is, well, let's figure out what's tan of pi over 4. What's tan of pi over 4? Okay, pi by 4 is right here. It's gonna be root 2 over 2, root 2 over 2. So tangent is of pi by 4 is 1. Okay, let's put that there. The other one is pi by 6, which is over here. It's going to be root 3 over 2, comma 1/2. So the tangent of pi by 6 is 1 over root of 3. Okay, so let's have that right nice and handy. So tan of pi over 4 is going to be 1 minus tan of pi over 6 is 1 over root of 3 divided by 1 plus tan pi by 4 is 1, tan pi by 6 is 1 over root of 3. Okay, so now let's bring it up there. 1 minus 1 root of 3. Well, how can we simplify this thing? We need to have a common denominator, right? Our common denominator would be root of 3, so we can go root of 3 over root of 3 minus 1 over root of 3 all over, what's the lowest common denominator here? It's going to be root of 3 as well, and it's going to be 1 times 1 over root of 3, so it's going to be root of 3 over root of 3 plus 1 over root of 3. Okay. So let's see if we can clean this up a little bit. So root of 3 minus 1 over root of 3. And in the denominator, it's going to be root of 3 plus 1 over root of 3. And I can see that, we can probably see that root of 3's cancel, right? Because they're both in the denominator. So our answer would be root of 3 minus 1 over root of 3 plus 1. And what's that? No, we can't cancel these things, right? This is not factors. So that's just how it is. Yeah, they're different. They're not factors, so we can't say, hey, these two are the same thing. We can't cancel those two. Okay? So that's our answer. And that is exact value. Exact value. Okay, good. Let's do example 3. Yeah. No, we won't be able to. Negative 2 minus root of 3.
Please go different route.
Oh, okay. Now, can I see that for a second? Okay. Now, if you type in pi over 12, this is what's going to come up if your calculator does special tricks like this. What happened is, okay, let's see. I think what happened, how they got that particular answer is because they rationalized the denominator. They rationalized the denominator. Okay, let's see if, I mean, in terms of factoring or canceling, reducing, we can't go any more further. But if we rationalize the denominator, let's see what that looks like. Okay, root of 3 minus 1 over root of 3 plus 1. How do you rationalize the denominator? You're going to multiply by conjugate. So conjugate of the denominator. So it's going to be root of 3 minus 1. Minus 1. I don't need a root of 1. And then root of 3 minus 1. So this expands to root of 3 times root of 3, so that's 3. Root of 3 times negative 1, negative root of 3. Negative 1 times root of 3 is negative root of 3. Negative 1 times negative 1 is positive 1. That's where the 2 came from. And then if we expand the denominator, root of 3 times root of 3 is 3. Root of 3 times negative 1, negative root of 3. This is going to be positive root of 3, negative 1. So if we simplify things in here, 3 plus 1, that's going to be 4 minus 2 root 3. This cancels. 3 minus 1 is 2. Okay, what happened here? There's a common factor of 2 that we can cancel out, or we factor out. So it's going to be 2 minus root of 3 over 2. Now, because this is a common factor, factor is something that's multiplied so that can be canceled by division. So this is what your calculator is showing, 2 minus root of 3, which is still a rational number. So sure, we can write that down. We'll put that in.
Can I have that paper?
Okay, this is a rationalized denominator. Okay?
We won't ever have to go that far.
Sometimes you don't have to. Sometimes this is...
Do not a lot of calculators do that?
Nope, not all calculators do that. Okay, let me try my calculator. 10, way to do. 10 of pi by 12. It's going to give me decimal. I think there's another student that has that same calculator as you. I'm not going to mention it.
Costco.
Oh, is it Costco?
Costco. $10.
Right. Okay. We're not advertising here. Right on YouTube. Okay, let's gonna do example number 3 because this is gonna take way too long. This is longer. This is even longer. Okay, so if you think that's long, this is longer. Okay, example 3. Given an angle alpha in standard position with a terminal arm in quadrant 2. Okay. And cos of alpha is negative 5 over 13. Negative 5/13. And angle beta is in a standard position with its terminal arm in quadrant 1. And the sine is beta is 3/5. Determine the exact value of that. Okay. Well, we don't even know what alpha and beta is, right? So we can't really do the same strategy as this one. Not the same. So how can we do this? Let's see. I'm going to break it up into piece by piece. So given an angle alpha in standard position with a terminal arm in quadrant 2. Okay, so alpha is in quadrant 2. There. And it says here, the cos of alpha is a negative. Okay. So terminal arm in quadrant 2, right there. And the cos is negative. So alpha is somewhere in here. So cos is the cos, which is here, negative 5 over 13. What do you think the y is? This is the x. The y is a positive value, right? Because it's in a quadrant 2. Cos is negative, sine is positive in there. Okay, good. Well, how can we figure out the y?
You consider if I radius 1?
Yeah, we can consider the radius 1. We can use our identity. This is the cos of alpha. Then the sine of alpha would be over here, right? The y. So how can we use an identity? What identity do we use? Yeah. Mm-hmm. Yeah, we could use that too. But I'm going to use something better. We're going to use this trig identity. Okay? So, oh, this is blurry. Okay. So, we know it's going to be sine square alpha is equals to 1 minus sine, cos minus cos squared alpha. This is much better, a little bit faster. So sine squared alpha is equals to 1 minus, well, our cos is negative 5 over 13. So I'm going to put negative 5 over 13 squared. Are you okay so far? So sine squared alpha is equals to 1 minus 25 over 169. So that's going to be sine squared alpha is equals to 169 over 169 minus 25 over 169. So sine squared alpha is equals to 144 over 169. So if we take the square root, we're going to take the plus and minus. We actually have two possible solutions in here. But it says here, the angle is in quadrant 2. So which one are we going to take? The positive or the negative? Positive. So we're going to take sine of alpha is equals to the positive 12 over 13. Because it says here, it has to be in quadrant 2, right? The angle is in quadrant 2, so it has to be a positive sign. Leave it like that, okay, because I need that later. Okay. What about the other one? Angle B. Angle B in standard position with the terminal arm in quadrant 1. Angle B this time is in quadrant 1. And sine of angle B is positive. So that's the sine of angle B is 3/5. We're going to look for cos of angle B. So how can we figure out the cos of angle B? Cos squared beta is equal to 1 minus sine squared beta 1 minus 3/5. Okay, so go ahead, pick it up from here.
What did you get on the end there? After you square rooted?
Now I gotta go back in here and say, okay, I gotta analyze something in here. I could possibly have two solutions for cosine, but then they kind of gave us a little clue here that it has to be in quadrant 1. So which one should I take, positive or negative? The positive. So cos of alpha is going to be positive 4 over 5. Oh, beta. Yeah, beta. Thank you. Come on. Hey. Okay, so what can we do next? Cos of alpha minus beta. We have no idea what those angles are, but we do know their components, right? Let's try over here. This is part.
Emergency? Oh, it's a test. That's annoying.
Okay, so it says here what we're going to do is we're going to use this identity to figure out the value of it. So cos of alpha minus beta, cos is equals to this. So all of the things that we've done in here, I guess I should have told you ahead of time. That's the reason why we had to figure out the both sine and cos, because later we're going to use it. These are the preliminary work to get into this piece. Okay, so let's go ahead and put those in together. Cos of alpha times cos of beta plus sine of alpha sine beta. Okay, we figured some of them out, or all of them out. We just have to put them in the right places. Okay, so what do I put in here for cos alpha? Cos alpha would be the negative 5 over 13. Negative 5 over 13. It says here cos beta. What are we going to put for cos beta? The 4 over 5. Plus, what do I put for sine alpha? It's going to be 12 over 13. And what do I put for sine beta? Okay, sine beta, that's this one over here that's given, 3 over 5. So let's see if we could just clean it up a bit. Okay, did you get 16/65? Okay. Is there, no, I don't think there's any common factors, so that's it. Oh, can you see how this much work is right there? Right? You're given some pieces of information. We're gonna figure this out. And that took us quite a bit of time. No. That, yeah, that's crazy. Yeah. Okay, so like I said, I'm gonna chop it up into sections. So we did examples 1, 2, and 3. So these are the ones that I'm gonna assign to you for practice. For practice. And we do need practice, right? Everybody does. Page 643. Question number 6, 7, 8A, and 13. Okay,